Today we are going to discuss on OSP on estimation of blood urea by diacetyl monoxide method, DAM method. Urea estimation can also be done by enzyme method such as urease method, but we will be discussing DAM method, which is non-enzymatic method. And it can be, as you know, OSP, for SP you will be sent to different station, and as such I'm just discussing the different station which may be asked, but it is not fixed that in station 1 the thing will be asked, but it depends on the teachers being involved and depends on time to time. Okay, as an example, in station 1 you may be asked to write the principle, where you have to write down when urea is heated with substances like diacetyl monoxide containing 2 adjacent carbonyl group on acidic medium, colored compound are developed. And for this reaction, for this experiment with the color development, you have to measure the color by the using colorimeter, and thus help in estimation of the blood urea. In station 2, you may be asked to write down a missing reagent in a list of reagent, but for you, I'm writing all the reagent, but this suppose third reagent may not be given or anyone. So all of them are like sodium tungstate, 10% sulfuric acid 2/3 normality, diacetyl monoxide 2% acid mixtures, which is of phosphoric acid and concentrated sulfuric acid. Stock standard solution of urea, whose composition is 250 mg dissolved in 100 ml, and working standard solution is prepared by diluting 1 ml of the stock standard in 200 ml of distilled water. So by unitary method, we know that this 1 ml of the stock will contain 2.5 mg, and when it dissolves in 200 ml, 1 ml of this working standard solution will have 0.0125 mg of urea. You should keep in mind this is involved in calculation. Now in this, another station, you may be asked to proceed for procedure stepwise. You have to do, and the mark will be given. And deprotonation step, in this step you may not be asked, but you should know, because when you do the calculation, this idea has to be there, otherwise your calculation applying the formula will be difficult, because the volume of taste we use will be only 1 ml out of the total reaction mixtures, that is from the reaction mixtures by deprotonation process. Okay, for deprotonation we take 0.1 ml of serum, sodium tungstate, then 2/3 and sulfuric acid, distilled water correspondingly with the values given here, and making a total volume of 4 ml, and it is mixed well and centrifuged for 5 minutes. Then the centrifuge, and then the supernatant is taken for the further taste. So okay, and this color development step is important, and I will show you the video also. And the amount you have to put in each test tube level will be are shown here, and after putting the corresponding reagent, diacetyl monoxide acid mixtures and distilled water in each of the test tube, they are incubated for 30 minutes, and color development is happened, and the solution is measured in the 480 nanometer wavelength in calorimeter, using calorimeter, firstly by making the blank at 0, setting the 0 at 0 in colorimeter. Okay, the step you just see, go through. Okay. Okay, after measuring the optical density, we will be able to find out blood urea concentration by using the formula blood urea mg% equals to ODT upon ODS multiplied by amount of standard upon amount of sample multiplied by 100. And out of this values, there are amount of standard. We know that 1 ml of working standard solution that we use in this procedure, working standard here 1 ml is 0.0125 mg of urea, as we have seen from the first previous slide. Okay, and for the second value amount of sample, how much sample we use? 1 ml out of the 4 ml of reaction mixtures that we do during the deprotonation process. Okay, that is why I mentioned about the deprotonation. So in the deprotonation, we use 0.1 ml of serum and making up a total volume of 4 ml with the other reagent of the reaction mixtures. So 1 ml that we utilize for the in the supernatant will contain how much? Will contain 0.1 by 4, that is 0.0245 ml of serum. We substitute value this here also, and we get a multiplying factor 50. And after measuring the ODTS and ODS by setting the optical density of blank at 0, we get the value 0.01 and 0.02, which give a value of 25 mg% of urea, blood urea. Okay. So next station may be asked for interpretation like what is the normal range of blood urea, which is about 20 to 40 mg%. And you may also ask about condition where blood urea level are increased. For this, you have to tell three separate ways, like pre-renal cause and renal diseases or post-renal causes. Pre-renal may be, example, dehydration, severe prolonged diarrhea, or severe vomiting. And then renal diseases like acute glomerulonephritis, hydronephrosis, and post-renal causes may be obstruction of the flow of urine, or tumor of the bladder, or this enlargement of the prostate gland. This is how we can there can be different stations and different questions can be arise. And in some station, if viva are permitted or viva are there, then you may be asked about what is urea, how urea is formed. So urea is an end product of protein metabolism, which is toxic. And then uremia is an increase in blood urea level due to kidney dysfunction. And azotemia, it is as you can say it is an increase in blood urea level or some other nitrogenous waste product in the blood level, and it is due to kidney disease or may not be due to kidney disease. Okay, this much I want to tell, and if you have any problems, we can discuss later. Thank you.